Hello, everyone, and welcome to Ghana JAG monthly meetup for the month of April. My name is Osborne Yao Sapati. I'm also a member of the community, and today I'll serve as the moderator for this event. First, let me give a brief about Ghana JAG, or what the community is about. The purpose of Ghana JAG is to promote awareness of Java and its associated technologies by hosting Java technology meetup, just like the one we have now, for developers, students, and other professionals who want to advance their knowledge and skills in Java. Our ultimate focus are, one, to learn more about the Java technologies. The second would also to meet experts and share knowledge and experience with friends and colleagues. We also find new ways using Java technologies to benefit our industries. Wonderful news about Ghana JAG. It's the membership, it's free. So if this is your first time attending our event, we greatly welcome you. So as a means of expanding our members or getting more members, we ask the members kindly extend a few invites to their friends and colleagues on social media. And whatever they also learn, they could also post it on their social media platforms using our hashtag GhanaJag or JagGhana, anyone works. This community is proudly sponsored by Turntable. So as you can see on the screen, we have our media. So we have on Meetup, you get us as meetup.com/Java user group Ghana. On Twitter, it's at GhanaJag. Then on LinkedIn, it's Java user group Ghana. Let me talk about our speaker for today. A little background. Our speaker started learning computer science since medium school, and thanks to a Commodore, he discovered the world of programming. He began working in C in 1998 and worked extensively in 1996 with Java using JDK 1.0. It was then called Java 1. He developed one of the first distributed objects applications in Italy. Then in the following years, he went on building large-scale applications for enterprises using RMI, Cobra, and finally Java Enterprise. In 1999, he coached one of the first groups that adopted extreme programming in Italy. In 2002, he co-founded the Java user group in Torino. In 2005, he was recognized as a Java champion and then became a member of the international community. He began promoting and teaching Java as a speaker for various developer conferences, such as Webbit, Agile Day, Agile Conference, Java Conference, Java Day, Devox, and today he's here with us at Java User Group Ghana. His dedication to the community, it's impressive. His dedication to the community as a Java champion has also been amazing and also helped spring up so many Java user groups. I am particularly elevated and privileged to introduce our speaker for today's session. He is no other person than Bruno Bossola. Hi, Bruno.
Hello. Hello, everybody. Can you hear me okay?
Yes, we can, Bruno.
Yes,
Perfect.
we can.
So from this, I will be leaving up the session to you, and we'll come back during the Q&A. Thank you.
Okay, so let me share my screen.
Yeah, I mean, you'd have to stop sharing for Bruno to share.
Oh, yes, thank you. Which is this one, share. Right. Okay, so this session today is about understanding software design and the principle that guides good design. As Uncle Bob Martin is a famous expert in software design, being in the field way ahead of me, and that's what he says. So that good code will always be faster in changes and modification than bad code, and that seems so obvious, but then we do so many mistakes, and most of the times we don't realize how different it would be if we just had better code. So we're already talking about me. Let's move on. So let's first talk about design. So what is software design? In particular, what is the meaning of design in software development? And what is the difference compared to analysis? So the one thing that you have to stick to your mind, and one concept that should be very clear, is that analysis defines what the system does. So what it does, while design defines how it does it. In particular, with design, you are defining the modules of your system, how they interact with each other, and their structure. And the better structure you have, the easier is that to change that code or to apply modification or new features, all that stuff. So that's very important. Because, you know, we wouldn't, in reality, we wouldn't really need design. Because if we were writing a program that basically runs once and then forget about it, we wouldn't need any design. Because we write that program once and then it's done, it's finished, the program disappears. So why should we care about the quality of the code? I'm never gonna change it. The problem comes when you have to change your code because you want to, I mean, there's a new bug, there is a new feature, you want to add this new stuff here, the new framework there, no? And at the end of the day, it's all about money. And this is something that is very important to explain to managers when they ask you, why are you spending so much time writing code? Why aren't you faster? Well, because I'm trying to write good code that it will cost less to be changed in the future. Having a good design in code helps to keep the cost of each change low. So if you have good code, adding a new feature, easy. Or adding a new, fixing a bug, easy. If you have complex code, it's going to be really, really, really difficult and take a lot of time. And time, in our case, means money. Money that the firm is going to spend to support the change that if the code was better, it would have taken so less time and so less money. So this is about money. And money is a thing that managers understand, well, usually. The first thing that you have to ask then is, how do I know that a design is good? How do I know this? And I suggest we pick this later and we move on to a second obvious question, no? Which is, how do I know a design is bad? No? How do I know if a design is particularly bad? What are the symptoms? Well, in my experience, this is how it works. So you say, this is not how I would have done it. I would have done it differently. So this is bad. But this, of course, is a very subjective interpretation of this, because there are no facts. This is not how I done it. For me, when I sit near somebody that have bad code, for example, myself, I feel very uncomfortable. I just want to scratch myself, start itching, no? And most of the times I stopped it, but I used to have a pencil, and I used to yawn, eat the pencil basically. And I arrive a point when I have to go away and have a coffee or a cup of tea because it's too much. But because during all these years, I developed a sense for bad smells, for bad code. So Kent Beck, which is another famous designer, talks about smelly code that smells. And there are definitely a lot of code smells that you can have, but there are some things that you can really recognize objectively So not because of you, but objectively in a bad design. There are 4 clear symptoms of bad design that you can explain, and you can talk, you can speak to people, and you can have a dialogue about it, and you can come up with some solution. So, but you have to know the symptoms. Those are the most 4 famous symptoms of bad design: rigidity, fragility, immobility, viscosity. So let's have a look at each one of them. The names are fancy, but there's nothing complicated really. They're really easy to explain. So rigidity is when you want to do a change. No? You really want to do a change, and you start doing this change. But then because you make this change, there is another thing to change. And then you change this second thing. And then again, there is a third thing to change. And then you change this third thing. And you basically have this effect of change after change after change after change after change never ends. So what started with like a 1 hour change, it's going to take you 1 hour. It's easier just at this. You end up in a week marathon. This happens because your code is rigid. This is the rigidity. You want to do a change, you ended up doing 1 million changes, not 1 million, but maybe 10 changes, 7 changes. You wanted to do 1. You have to do change in every single dependent module. Fragility is another one, which is also funny. So it happens when you change something and you're done, you did the change, no? But then a completely unrelated area stops working. So completely unexpected. So for example, you change the database, no? You change something on the database, the default order of a column, I don't know, the length of a field, no? Which is simple change. But then somehow, I don't know, the invoicing UI stops working. This is because your code is fragile. So if you do a change in a piece of code, this change kinds of reverberates and infects areas of code that are really not connected, that have nothing to do about it. This is called fragility. I change a thing, if another completely unrelated thing breaks. Third one, immobility. This is also very interesting. So you have, it happened actually to me today. I was trying to extract a piece of code that was really good. It was a really good piece of code. I really wanted to reuse that piece of code. A lot of work went into it. It was a very complex business logic, and it's going to be difficult to build again. But then when I tried to extract it, now when I tried to extract that piece of code, there was a lot of other pieces that were coming with it, which I didn't want. So I want to extract this interesting business logic to do whatever I was doing. And then other unrelated pieces come to me. So I have to also take, I don't know, a piece of the UI, a piece of the database, a piece of this logic. What is this? I don't know what this is doing. So your code is immobile. You cannot move it. It's nice. It's there. You would like to use it, but you cannot move it, because if you move it, you take with you a lot of baggage that you don't want to have. This is called immobility. The last one, which is also very common, is viscosity. So viscosity happens when you have a decent design in front of you, not bad, and you need to do the usual change, no? But the issue is, when you try to do a change, you suddenly discover that it's very difficult. And you see that there is a simple hack that you can put in place to solve the problem. So what I'm trying to say is that the cost to do this change following the existing design, it is so high compared to just placing an if in the right place, or whatever you want to do. So it's, with a few lines of code which are completely stuck, you just drop them there, your problem is solved. But if you do that, you don't follow the existing design. You just hack into it. No. So viscosity happens when it's much easier to write a hack to solve the problem than following the existing design. And these 4 principles is something that you can talk about. So these 4 symptoms, sorry, is something you can talk about, because it's always, when you have the code in front of you and you talk to a colleague, you can talk about it. Look, this code is too rigid. So I just wanted to change this, but then I have to change this and this and this and this. It's going to take me forever. We have to change this design, make it better. Or I don't know, fragility. Look, I would like to change this, but once I changed it, the front end stopped working. And I don't know what's the problem here, because there's nothing related here. I changed the back end and the front end. And another part of the front end, by the way, not this one, stopped working. I show you. Immobility. I really like to have this piece of code. I really like to have it. But I cannot take it, because if I take this piece of code, also these other pieces, I need to take them. But everything becomes, it's too much. I don't need all this stuff. I just need this routine here. Probably this set of routines here, but I don't want to get all of it. Look, viscosity. Look, you see this? So I can just make an if here and everything goes okay. But if I place a if here, what I'm going to do with these factories and things that we have here, what's going to happen to them? I don't think it's right. We're just hacking into it. We're not doing anything proper. And those are the 4 symptoms of bad design. So hopefully, now we have an idea about what is bad design. However, the question that we have is why bad design is there in the first place. I mean, we're not intentionally bad developers. I mean, any of us can write decent code. Maybe, of course, somebody's better than other, but nobody starts writing code with bad intentions. So there's something that we can try to understand to make sure that we're writing good design. And the first thing that we need to understand is, do we have any metric, objective metric, to measure the quality of design? And yes, there are 2 metrics actually that we can use to measure this. And the 2 basic metrics, the most famous, are cohesion and coupling. No? And those are not new, because they were created like 50 years ago, so they're not particularly new. But there's a lot of people that don't know those things. Hopefully most of you know, and that's absolutely fine. But if you don't, then you better get on with it, because they're really important. So what are those? So cohesion is, well, technically the measure of the strength of the semantic or conceptual relationship between blah, 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 blah. I don't understand it. So no, I do understand it, but it's too complicated. So it's basically how something is focused on a specific task. No? How something is related to what it's doing and is not doing other things. So if a module, a piece of software, a module of software is focusing on one specific thing, then it's cohesive. And the trick in good software engineering is to keep the cohesion as high as possible. So having things very specific, do very specific things, and we'll go through that later. But remember this cohesion, no? How this module is related to what it's doing. It's doing too many things, doing one thing. And coupling is when you have different modules and they are somehow connected together. Maybe not in this extreme way, but something along those lines. So the thing is, if 2 modules are coupled, they cannot change independently. So if you change one, you have to change the other one. If they are decoupled, it means that you can change the one and then nothing changes on the other one. Later you can change the other one and nothing changes on the previous one. So they can basically change independently. So you have to really remember those two concepts, cohesion and coupling. So you always want to have high cohesion. So things that are doing one thing and only that thing and not other things. No? And they're really, and even if you see them together, not only one module, if you see a set of modules together, you can see them cohesive in what they're doing. So the part of the subsystem that manages the database effectively manages the database. It doesn't do other things. It doesn't export things for the UI, for user interface, or stuff like that. It's just doing the database. And low coupling, again, you have those things, you have those modules that, however, can change independently. So if you change module A, you don't have to change module B. And by module, by the way, I intend any abstraction you have in your software. It can be functions, modules, objects, classes, whatever, however you want to see it. No? So bad design, rigidity, the endless marathon of changes, fragility, I change here, it breaks over there. Immobility, I like this code, I cannot take it because there's so many things attached. Viscosity, it's much easier to do a hack rather than doing the right thing, following the design. High cohesion, low coupling, we'll discuss it now. So this is about bad and good design. And these are some tools that help you to understand the problem. No? The fact about by design will tell you, give you a point to discuss, to talk to people and understand and figure out what's wrong. And the good design metrics, again, you have to keep that in mind to understand where your code is going. However, you may need something else to to write good code, because you need to have some sort of tooling that helps you to write good code. And what I usually suggest is a set of principles. So don't get me wrong, there are a lot of ways to write good code, a lot of different ways. I think nothing is bad, absolutely. So having nothing is bad. One thing that I think is worse is blindly using, for example, patterns. I just want to mention it here. I don't know how many of you know design patterns. You may have heard of them with names like factory, abstract method, or singleton, or proxy. Those are all patterns. So patterns are good. And I personally know all of them by memory. I can recite them to you. I think I can still do it. But patterns are recipes. And recipes don't make you a cook. So if you ever try to cook something based on a recipe, and failed miserably, like I did several times, because why you're failing? Because you don't know the principle. When they say a pinch of salt, for example, how much do you put it? Well, they think about cooking, slow cooking. What does it mean? What's the temperature here? What should I do? Or do I don't know, do this particular sauce, but you don't know what is. I mean, you have the ingredients, but you don't know what will be the consistency of the sauce at the end. So patterns are like recipes. Recipes don't make you cook. So the worst thing that you can do in design is just applying patterns without understanding the underlying principles of this pattern. Because these patterns were created by expert people, that they wanted to give you some ready-to-use tools to do your stuff. And it's all good. But again, if you are using them blindly, you're probably going to do more damage than good. And I saw this happening multiple times. And it happened to me. Don't get me wrong. I did the same mistake. I didn't know about this. When I started coding, well, when was it? In 1988. But then I started using Java in 1996. Then in 1999, I knew all the pattern. And I made so much damage because I didn't know what I was doing. Oh, let's put here a factory. Let's put here a proxy. Oh, let's blah, blah, blah. And no, it's just, no, bollocks. Don't. That's not the way you should do it. The way you should do it is using principles. Principles that guides you to good design. And you know, you will eventually develop your own patterns. You will get your own patterns. 90% of the time, 99% of the times, you will reach the same patterns that you study on the books of patterns. But the good thing is that that will be yours. You did that. That's extremely important. So this particular set of principles are not the only ones. There are several others, but those are the easier to grasp, I would say, and the most accessible. So that's the reason why I wanted to discuss about this one. SOLID is an acronym of acronyms. Was basically created by so that you can read it. No, you can read it vertically or horizontally. So horizontally, these are the 5 principles: single responsibility principle, or SRP; open-close principle, OCP; Liskov substitution principle, LSP; interface segregation principle, ISP; and dependency inversion principle, DIP. And if you read them in vertical, you can see you read SOLID. That's a nice trick, but that's how you remember them. I mean, now I remember, but if you don't remember initially, you think about what is what. And then if you search on the internet, you find a lot of references on this. Usually, there's mixed approach. People may or may not understand them. I will try to explain those to you. They're not super easy, but I think they're the most accessible one. And all those principles are based on the 2 metrics of good design that we saw before: high cohesion, low coupling. So things that know exactly what they're doing and they're doing that, and things that can change independently. All right, so let's start with first, single responsibility principle. So this, this is somehow, if you want, an extreme violation of the principle, no? You know, the Swiss knife, no? And you can put everything in it, and you can end up having this kind of thing, which is why. Just because you can doesn't mean you should. So you can stuff a lot of things inside a Swiss knife, but it doesn't mean that you should have all that stuff inside. And the same comes with software modules. So the single responsibility principle says that a software module should have a single responsibility. This is not easy to understand, because this concept of single responsibility, because some people end up saying, oh, then I just have one method in my object, or one method in my class, or I don't know, whatever other weird idea comes to your mind. No, you still have a class and an object with all these methods, attributes, and operations, but it doesn't mean that it doesn't do one only thing, and one thing only. And the way to measure that is to look at the reason to change. So you look at that thing and you say, how many reasons to change does this module have? Why I should change with this module? For which reasons? And the answer is one reason. There must be one reason why you change that thing, why you change that class, that object, that function, that package. There must be one reason only. You can expand it all over the place. You must have one reason to change that. And we can have a look at a very simple piece of code. No, I mean, this is just very, it's an obvious example, extremely simple. So I just use these very simple examples to make sure that everybody understands what I'm talking about. So don't feel bad about it. It's just that the simple is better. Every time you have a complex problem, make it simple first, and then you can understand it. Then after you understood it, you can solve it. So going back to here, we have basically two classes, no? Modem and employee. Modem, I mean, yeah, that is a bit age. It's a bit aged, this concept. But once upon a time, you used to have these small boxes on your desk that do no, and connects you to the internet. It was dial-up modem, so you were using your normal telephone line to connect to an internet provider. You still have modems, so they are inside your router or aside on your router. If you're using I don't know, a very fast internet access, you still have modem. But those modems were the very origin of them. And with this modem, you can dial a number, you can hang up, you can send a character and receive a character. Yeah, it wasn't that fast at the time. It was really, really slow, like 300 characters per second. So you can imagine.
Hi, Bruno.
Yes.
Please, could you turn up your camera for us? It seems we can't actually see you. It's all blank.
Oh. Can you see me now?
No, we still can't.
I don't know, because the camera seems to be on.
Okay. Bruno, is your background up?
No.
Okay, you don't have a background?
No, I didn't. When I tried to add the background, the system crashed. So okay. I just, I'm sorry, I don't know why it happened, because I tried yesterday and the day before yesterday and everything was working. And unfortunately now it's not going through. Do you want me to try to connect using the web interface? Maybe it will work from there.
I think. Could we just read?
Continue.
Yeah.
Yeah, we can still
okay.
Continue.
I'm really sorry about that. I don't know why my computer is acting up today. Yeah, I know. I checked, and there are no other apps using the camera. I can switch on and off the camera, and it shows me the preview when I connect it, and then it doesn't show me anymore. So I'm afraid that I don't have a solution for that. Oh, you're not missing much. You're not missing much, to be honest. So if you go back to this example, let's go back to SRP. So does this modern class support SRP? That's the question. Now let's go back to another example, the employee. Now we have this for method. So this is an employee class, probably in some form of system, and you have a way to calculate the pay, a way to write a report, and a way to save this information about the employee and reload the information about the employee, possibly from a database or whatever this information is stored. So, do you see SRP supported here or not? I will give you a second to think about it. And I can go back to the answer. The answer is no. SRP is not supported here because there are different reasons to change these classes. So look at the modern one. If suddenly I'm able to send or receive differently, I will have to change the modem. But at the same time, if I have to change the way the line is connected and disconnected, I have to change the modem. So the model has two reasons to change. One, because of the line, the connection to the line, and the second, because the way it sends characters across the string. So no, this doesn't support SRP, and you will probably need to find a different abstraction to express the same thing. The same for the employee. So the employee has a calculation method, which probably does something with the salary, pay, I assume it's a salary, no? Then you have a way to write the reports, and then it has a way to store, to read and save itself on the database. So there are three things here. So there are three reasons why this object can change. If the way the pay is calculated, I will have to change this object. If they want to change the report, the way the report is written, I will have to change this object. If I want to change the way the employee is persisted because I'm moving from database A to database C, I will have to change this object. So this object is doing too many things. It has to do one thing. Which one, I don't know. I will need to do the rest of, to look at the rest of the system. But for me, it's clear that this object is way too busy. Too many things to do. And the way to address this problem is, of course, to look at the design and say, okay, how can I separate this? And I can move this responsibility elsewhere. I may have a database object that saves and reloads the employees. Then I might have a reporting PDF report that is able to create a report for an employee in PDF format. And then I have a printer report that prints on the printer the report. And then in regards to calculation, I might have another thing that do the calculation. No, it may be the employee is just classes with some basic data and some very basic behavior related to the employee itself. No, so this is something that something you should think about. So how do we follow this principle? So we have to group together things that are changing for the same reason. So things that are changing for the same reason go together. Things that are changing for different reason go away. Be aware of things like manager, controller, handler. Those are all BS. I don't say they're not bollocks. So when you see a class called manager, it means that who wrote that class probably wasn't able to define exactly what it was doing. The manager, what does it mean, the manager? It manages stuff. It means nothing. Controller, it controls stuff. Yeah, sure, of course. Handler stuff. Oh yeah, I'm handling this. What does it mean? This just means when I wrote this code, I had no idea what I was doing, and I just had this fancy name to protect me from from my own failure. So it's incredible how good names help to understand things. So another thing to do, use good names, spend time to name things based on what they do. We will be paid dividends for that, I can guarantee you. Open close principle. Yeah, open chest surgery is not needed when putting on a coat. So the open close principle is also very important because it says a very strange thing that you immediately think, oh, how can I do that? So the open close principle says software modules should be open for extension but closed to modifications. No, that's what it says. And it's from 1998 by Bertram Meyers, a small principle. And basically it says you should add code. You do not change code, which is weird, no? How do you add code without changing code? So how does that work? How can you do it? And of course, there's a little bit of change always, but because you cannot always have everything structured like this. But the intention is to keep always your code open for extension, but closed to modifications. Some of you might remember Smalltalk. Smalltalk was one of the first object-oriented languages. What you need to know about Smalltalk is just one thing. It doesn't have if. The if construct is not present in Smalltalk. And they did a lot of programs with Smalltalk, a lot of them. So whenever you think that object-oriented programming is difficult, think about that. It's possible. I've wrote program without ifs. It's just that it's challenging. But going back to the principle, you add code, you do not change code. So do we have OCP here? So this is a piece of code that writes shapes. So it receives an array of shapes, and then for each shape, it draws it. And basically checks on the type of the shape, and applies different drawing function based on the type of shape. Oh, if it's a square, then I'm gonna draw a square. And if it's a circle, then I'm gonna draw a circle, and so on and so on and so on. Do we have OCP here? Well, the answer is clearly no. Why? Because every time I have a new shape, I will have to change this code. So if suddenly I have a triangle, no, and I have a fantastic algorithm to write triangles that is super optimized and fantastic and amazing, I will have to go here, change this code, and put case shape.triangle, draw triangle shape or whatever, right? And then, you know, it's a switch. So switch is also very tricky. They're changing it in Java, the latest Java version. But there are so many of them. They're changing and removing this break and stuff. They're making it much easier to do. But sometimes you have this switch that's gigantic, like 20, 30 switches. And sometimes it happened to me, I forgot to put a break. So what happens is that when you don't have a break in the switch, the second instruction is executed right away. So it's very complicated. So how do you solve this with OCP? Well, you have to introduce the proper abstraction, and you end up doing this. So the change is that now draw is a method of shape. Shape will have subclasses like it has in the previous example, but the draw method, instead of being squashed somewhere, it's inside the class. No? So each shape will know how to draw itself. And you end up from this to this. And I know this is a very simple example, and you can say, yeah, of course. I guarantee you, every time you put a switch or an if, you should think about it. Can I do it differently? Do I really need a switch here? Can I do it in a different way? And look at your code, go there, search for switch and ifs, see what happens. You will find plenty of them. So how do we follow this? Introduce the right abstractions. No? Always choose towards cohesion and low coupling. So try to write things that are really cohesive by themselves. And again, keep the things that change frequently away from the things that don't change. Word of caution, remember to do this strategically. You cannot do this everywhere. You have to do it strategically in the area that you think there will be more changes. You have to do them there. Okay, well, that's pretty much it. So we have one thing about abstraction that I mentioned. In software engineering, abstraction is the selection of those aspects of reality that are relevant to the problem. So for example, imagine a car. Okay, there are different abstractions about the car. A car moves on a road and has its own location and its speed. That's one abstraction. Another abstraction is, oh, the car has 4 wheels and a bonnet and seats, and maybe people in it. Another abstraction. So when you select an abstraction, try to select the right one, the one that's relevant to the problem that you're trying to solve. Don't be carried away and do other things that are not needed. Just find the right abstraction. That's always the key. So, Liskov substitution principle. Barbara Liskov is very famous for in the distributed systems field. I'm passionate about that. Did a lot of work about distributed clocks and stuff like that. But he's also produced this gem, which is incredibly important. No? And this is very true. If it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction, because they're two different things. What Barbara says, apart from this complicated definition of herself, and the one with Martin is also easy to understand, thing is, code that uses a class must be able to substitute it with a subclass without knowing it. So if I have a piece of code that uses the class balloons, I can give you a subclass of balloons to that code, and that code will continue to work. Because the subclasses of balloons are completely substitutable to the balloon. And this might not be so obvious. The classic example is the rectangle and the square. No? So they seem very similar. In fact, a square is a rectangle, no? It's just a rectangle with the same sides. Cannot we just create a single class rectangle and forget about square? No? But they have an area, perimeter, and so on. There is this problem of the different sizes. So rectangle has a width and a height, sorry. And while the square is the same, but we could manage it, no? We can just, when we set the height, we set also the width for a square. We do some trickery like that, and it would probably work. And it won't, because there will be programs in this universe of programs. There will be programs that are expecting to deal with rectangles. And when they receive this rectangle which behaves strangely, they won't work. They would assume that they will change the height. The width is not affected. No? But if you want to keep a square, whenever you change the height, you have to change the width, and vice versa. So those programs will not work. So it's very important for your subclasses to be substitutable. Again, select the right abstraction. Subclasses should not add any extra behavior. Subclasses should not modify any existing behavior. They can enhance it, make it different, make it particular for the thing, but they should not modify it. No surprises when using a subclass. Everything should work exactly as I'm using the interface or the base class. Interface segregation principle. Okay, so this is about having interfaces segregated. So rather than having this big block of interfaces like in the picture, there are, I don't know, 4 things. You have to want one clear interface that does one thing. It's the same. It's similar to the SRP, but for interfaces, not for object classes. So, because when you have these big interfaces, the problem with you have these big interfaces like this one, the one with all the boxes, the ticket, the knocks and the buttons and all these things. When you have these big interfaces, you end up and you depend on one of those big interfaces. Your whole code starts depending on these big interfaces. And usually these big interfaces, they are not very well crafted. And again, they have different reasons to change. And whenever this interface changes, this is a cascade effect on all the classes that are using that interface. So you don't want to depend on something you do not use. So you want to be right, cohesive interfaces. So I'll give an example. So here we have a bird interface. Okay? A bird can fly, can walk, can eat, can sleep, and other things, but we just reduce it. Any problems here with the birds? All good? Well, we do have a problem. The penguins and the chickens are going to be unhappy. They cannot fly. So this interface is not for them. We need a flying bird or something here. We need a bird. It might be a flying bird and other things. So this interface looks nice and dandy. It's not, because the poor penguins cannot fly. The kookadoodle cannot fly. So that's a problem. And if I assume that, again, if I assume that they can fly, how do I implement the method fly? I throw an, I don't know, supported operation exception. But if I do that, I violate LSP, remember? My classes must be substitutable. I cannot substitute this, and all goes very complicated. And you don't want to be in that situation. You have to write a smaller interface that do one thing and one thing only very well. So basically use SRP, the single responsibility principle, also on interfaces, so that they express a single responsibility. Of course, you want to be pragmatic, so sometimes you will have to have slightly bigger interfaces, but plan it well. Don't go and just forget about it. Apply this principle, because it's not only about birds, that I can guarantee you. The last one, the dependency inversion principle. The title is wrong, sorry. So this is very true. Why would you solder a lamp directly to the electric wiring in a wall? So why do we have this thing with plugs and things that go into plugs? Why do we have them? Well, because we don't want to have high-level modules depending on low-level modules. So I don't want to have my TV depending on the wall plug. I don't want to plug it directly with a screw or something. I just want to plug it and plug it with a clear interface. No? And the thing that you have to remember about this one is that abstraction should not depend upon details. Details should depend upon abstraction. Let's see with an example which is slightly easier to understand. So this is a classic one. Imagine you have, this is very simple, the dependency inversion principle. You just have to grasp it in your mind. So you have the transfer class and the bank account class. So the transfer contains the business logic. The transfer is the business class. It contains a lot of complexity in there. No? And basically it's able to transfer money from one account to another for a certain amount. It has a lot of stuff going on inside this class. It's a very complicated class. And then you have the bank account, which is basically a record on a database. It has a number, an account number, a balance, and then a method to add and remove funds. That's it. No? The problem that we have here is that the transfer is connected directly to the bank account. And the transfer is the business logic. The bank account is a detail. So today is the bank account, but tomorrow there is the, I don't know, the saving account or some kind of different account, or we have cards, we have cryptocurrency, we have all these things. How do we do this? Oh my God, those are all details. I just want, the transfer is the complicated thing. No? And the way you do it is obvious if you think about it. So you just create an interface called account. So the account will be an interface that has all the method that the transfer needs. So the transfer depends on the account. It doesn't depend on the bank account, on the wallet, on the card, which are all implementation of the account. So this way, you basically can make sure that whenever a new account comes in, the transfer is not affected. So if you need to change some details in the bank account, the transfer is not affected because the interface is clear, it's there. There's nothing fancy about it, but it works. So that guarantees you that the business logic in the transfer object is not affected to the changes into account. So again, hopefully this is something you already mastered. It's absolutely nice and dandy. But it's a very important principle. business logic should not depend upon details. So you always depend on abstractions, not on concretes. You have to make sure that the high level modules don't change because the low level module changing. And the low level module can be substituted without big impacts on the code. Okay. So this was the D in solid, and I think we are done with the slides. I think I made it on time with 2 minutes to spare. And I hope that you understood most of it. You will have the slides, and you will be able to look at them. And again, my Twitter handle is here on the bottom. And if you need anything, just tweet me or send me an email. I will put also my email on the slides. I probably forgot. I will put also my email so you can reach me by email and ask me questions. I'd be happy to answer. Although this is a very foundation lesson, is very important. I received it in the year 2000 and completely changed the way I'm coding. And of course, I compressed this because for me it was a training of several weeks. I compressed this in 1 hour, so I don't know, it would be difficult for you, but it's really important. Remember, what is bad design? How do you define bad design? High cohesion, low coupling, and solid principle. I'm done.
Okay, thank you, Bruno. That was a wonderful presentation. I really learned a lot. They say it's always good to adapt to the knowledge you have. So thanks very much. Now we'll take up questions. Yes, time for questions and answers. Anyone with a question? If you have a question, you could. If you have a question, you could type it. I could just resume.
I think there's a hand up, Moses.
Okay.
Yeah. Moses, please go ahead and ask a question.
Hello, please, can you hear me?
Yes, Moses, we can.
Okay. Good afternoon once again, and thank you very much for the presentation. That was lovely. So my question has to do with the open-close principle. I've always had a problem understanding this because the idea is we should make our classes or methods extensible. So we shouldn't modify the class itself, but rather give room for extensions.
Yes.
But what I keep finding in the code is that it's very difficult to actually extend something. Let's say class or a method, the capabilities, even though the extension maybe probably concerns the class without modifying the class. So I'll give an example.
Yeah.
Let's say I have a validation, a custom validation class. It handles everything related to validation. Let's make it string validation. Then now I want to extend it to handle, probably I was using, let me switch to Python. Please, are you familiar with Python?
Yeah, I'm good.
Okay, so let's say I was using Python too.
Yeah.
I wasn't dealing with the Unicode strings. Now I wanted to handle Unicode very well, and I want to extend it. Would that mean that I have a bad code because I would have to go into probably the class itself and modify some of the methods to now handle the Unicode strings properly? Am I breaking the principle?
Well, when I see a validator, I always think about having a set of validators, no? That they do react differently based on the input. So I have a validator for number, a validator for strings, a validator for this and that. So validator for currency, a validator for floating point, and you know, that's how I think about it. So your problem is very particular because you previously were handling string with no Unicode, and now you're handling string with Unicode, right?
Yes.
Well, you can. It's a very corner case based on the specifics of the language, because this problem is very important in Python. In Java, for example, you have this concept of encoding very deep in the language, so that in a way they're easier to manage compared to Python, and not. It depends how you look at those. So,
Okay.
but in general, if for normal cases, you should be able to just add a class. For this particular situation, when you have this particular problem related to a language, this is something that you probably didn't know before, or maybe you did, but you thought, okay, it's not very important, and that's okay. You don't have to apply the open-close principle everywhere, every time. It is something that you apply when you think there will be a reason to change there, no? And you won't always get it right. So it's absolutely fine if it happens that then that you find a case, oh, I didn't think about it, now I have to change the code. But what I usually do is that when I do this for the third time, so if I do once, okay, it's fine, I did it once, I made a mistake, it's fine. If I do it the second time, and sometimes the third time, I just sit and see, okay, I need to refactor this code because I already changed it twice, 3 times, and now it's too complicated. I have to refactor it, and then I apply the open-close principle.
Okay.
Makes sense?
Yes, that makes sense. Perfect sense. Thank you very much. I'm moving to Java.
Yeah.
Java specifically. Say I have a class that I'm trying to get the right example. So in Java, I have a class that probably serves, let's say, as a facade. So I'm using a facade pattern. I don't know whether I've got the name right.
Okay, facade. Yeah, that's fine.
Yeah, facade. Aha. So it's sort of imitating what happens when someone walks into an electric house. You walk in, it turns on the light, it turns on the TV, it increases the volume, everything like that. So with something like that, if I see I am going to apply the open-close principle to it, and I'm leaving room for extension, say the new extension I'm trying to include has to do with a bicycle. I have maybe an electric bicycle I want to move around just to make my pet entertained. Once I include that function within the pattern, so a function to maybe make an electric bike move around to entertain a pet, wouldn't I need to make a call for it somewhere within the class? Does that break the principle?
Well, what I would do in that situation, because you basically want to execute an action whenever somebody enters the room or something like that.
Yes.
So
a set of actions.
Yeah, I would probably extract this abstraction of an action. So I would identify this abstraction of an action that can be executed. No? And then I can pile these actions. I can do different implementation of these actions. I can have the bicycle moving, the switching on of the light, switching on the fridge, I don't know, whatever you have there. And I can, but they're all in the same interface, the action interface. So I will just have a set of actions ready to be executed, and I can change this set of action as I want. So I can create 3 action, 20 action, 2 actions, depending on what I want to do. And when the trigger happens, then I will execute all the actions one after the other, or in parallel, I don't know, whatever you want to do it. And regardless of how they will actually do. Does it make
Okay,
sense?
so if I get you right, you are abstracting the behavior from it.
Yeah. We'll extract this concept of an action, this abstraction. So, oh, an action must be executed when somebody enters in the room. I will extract this concept. And
Okay.
then I will create different implementation of this concept. Okay, what kind of action? Move the bicycle, move the, or switch on the fridge, switch on the light, these kind of things. And then I will just prepare a set of actions that I want for different people. I don't know if this is your problem. So if the kid comes in, there is a certain set of action. If the dog comes in, there's another set of action, all already prepared, and I will just execute them on the spot when I see the person entering the room, the trigger happening.
Okay. That's actually a very nice way of going about it. Thank you very much. Wow.
And it respects all this principle, by the way, most of them.
Yes.
Okay.
Yes.
All right. Thank you for your question, Moses. There is also a question that's coming from Samuel. Samuel Boateng says, what resources did you use to help yourself practice the solid principles?
I do, it's a good question. So what I do, I usually share my experience with other people. So of course there are books, and I can point you, I can put some books in the presentation. I will send you the books links. So that's an option. But to keep exercising, to practicing, the only way is writing code and having a review, having other people reviewing your code with the principles in front of you, solid or even just a bad design principle in front of you, and talk to each other. So the best practice you can do is being humble about your code. I know all developers ourselves, they all care about our code. They are really, oh my God, we don't want anybody to touch it. But you have to be open, and talk to somebody else, be open and learn from it. And if you don't want to use your production code, use some other code, some exercises that you do, that's absolutely fine. But have the principle in front of you and see, is this respect, and talk to the other people and see what they say. That's the best way to keep practicing, really, talking with other people, which understand the principle, of course, not to single function developers. I don't know, there are people that like to put everything in one line. I mean, it's good, but I cannot read it too much.
Okay, there's also a hand up, Bennett. Please go on with your question.
Hello, am I audible?
Yes, we can.
Yeah, so I have two. Okay, so my first one goes with, I don't know, I would like to contribute to the question that Moses asked. I want to contribute because I also want to clarify if I really understood what Bruno said. So about trying to abstract away that particular method, I know of this design pattern called template method. So where we have a series of actions. So we have methods that do different actions. And we have this static template method where all these actions are piled up. But this abstract class or interface will have all these actions. And those actions that are more generic, their implementation reside right within the interface or the abstract class itself. But then those that are more specific, that maybe different classes would want to modify or have their own implementation, that becomes an abstract. And then any other class that extends or implements that abstraction would provide its own version within that particular scope. So let's say within that template method, we have switch on the light, maybe turn on the TV, and then maybe probably turn on radio. Then let's say turning on the TV is where you want different classes to do different things. Maybe some classes would want to do some side stuff before turning on the TV. So within that template method, you organize the actions. So turn on the lights will come first, turn on the TV also come, and then the last one probably do something else. Then that middle action in that template method will be substituted by the different classes that have their own form. So when the template method is being executed in the context of any class that extends that abstract class or that implement that interface, it will run that method. But when it gets to the point where the abstraction or that particular information resides within that class itself, the class will replace it with its own implementation instead of using what is in the interface. That is for the Moses question. Maybe Bruno will also add up. My second one has to do with another clarification, and that has to do with the interface segregation principle. So if I understood it correctly, so it means that here we are saying that our classes shouldn't depend on things that they don't really use, right? So
yes,
let's say a class is requesting for, let's say, banana, but then you bring banana and then you also bring an apple or you bring something else. So which means it's possible that we should make our interfaces as very lean as possible.
Yes.
An interface can even have just one method, right? Or even two methods. So we break our interface up so that if we need them together, let's say a class needs 2 or 3 features from different interfaces, then we compose them and that class can use it. That's what it means, right?
Yes, that's correct. Again, it's a choice. I'm sorry, I have to drop because I have a meeting now coming up. But I suggest maybe if you can drop me an email if you have other questions, I will be very happy to answer. And if you want to share this code, or some code that you want to look at, we can definitely do that. I'm sorry, but I have another meeting that I need to jump in now. But I just want to really thank you for the opportunity to speak here. If you want me to speak about something else, I'll be happy to do it again. Maybe not very soon, but in a couple of months, yes. And again, if you have any question, anything that you want to ask about this, I will send you the slide with the email on. Please send an email and I will answer. I promise that. Okay?
All right. Thanks, Bruno, for your time.
Thanks for you for having me again. And have a nice rest of the day. And yeah, code with good design and solid principle.
All right. Thank you.
Bye-bye.
Okay, bye. So on this note, could you switch to Bruno's handles for our views? Okay, so on our screen now, you can see Bruno's handles on Twitter, LinkedIn, and you could also get to him on this website too as well. So on this note, I would say thank you all for attending. We're glad that you came, and we also hope that you've learned so many things.